All right, so we've talked a little bit about some cosine problems in one of the podcasts. Again, you could do the same thing for sine. So if you had, say, like, sine of 195 and you're trying to figure out an exact value, because that's what the directions will say, then you're going to have to split it into two things that are on the unit circle. So like in this case, I do that. Now again, remember there's going to be like sine, sine, cosine, cosine, or sine, cosine, cosine, sine, something like that. So this one, if you look on your trig identity sheet, is sine, cosine, plus cosine, sine. And then all of these should spit out ratios. So they eat up angles. So these are all angles, 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 angles. So these are going to spit out ratio, ratio, ratios, ratios. So half square root of 2 over 2 plus, and again, what's your negatives there? And square root of 2 over 2. And again, after you do this algebra, you're going to get what? Square root of 2 over 4 plus a negative what? Square root of 6 over 4. So square root of 2 minus square root of 6 all over 4. And again, you see those numbers over and over again. All right, so we've done that with cosine. There's an example of sine. Now with tangent, if you wanted to, if you were stuck on a test, all right, and you're like, I have no idea, I don't know what tangent is, but you know sine and cosine. So if you wanted to, for both of these, you could go ahead and write this one as sine of alpha plus beta over cosine of alpha plus beta and actually work all that out. This one you could do sine of alpha minus beta over cosine of alpha minus beta and work it all out. But someone did all that work for you. And again, these are on your trig sheets. So you don't have to memorize them. You just have to be able to use them, which again is half the battle. Sorry. All right, so I got that. And over, this is plus. Okay, all right, and so say again, how would you do this? Say I gave you the tangent of pi over 12, and again, I wanted an exact value, okay? So the problem is that is not on the unit circle, and so you need to split it into things that are. Now, if you're like, well, how do I get pi over 12? You might want to take things like pi over 6, pi over 3, pi over 2, pi over 4, things that we typically see on the unit circle and get a common denominator of 12. So, do something like this. Sorry, 6 and 6 and 3 and 3. Just so you can kind of think about what would add or subtract to get this. So in this case, I used, let's see what I do, pi over 3 minus what? Pi over 4. Right? Because that would be what? 4 pi over 12 minus what? 3 pi over 12. So that equals obviously 1 pi over 12. So again, that's kind of how I think about these a little bit. All right, so now I'm going to sub in and actually use the trig identity. So I'm going to use the minus one. So I'm going to use this one right there. All right, so I get tangent of pi over 3 minus tangent of pi over 4 all over 1 plus tangent pi over 3 tangent pi over 4. All right, so again, you can use your unit circle and look at these, but remember your unit circle doesn't give you these right off the bat. You have to do a little division, right? Okay, so sine divided by cosine. So for this one, my sine is square root of 3 over 2 divided by my cosine, which is half, so I'm going to multiply by the reciprocal. That guy is square root of 3. Pi over 4, right, is square root of 2 over 2 divided by square root of 2 over 2. I know that's 1. All right, then over here I get 1 plus, the tangent's the same thing as it was up there, square root of 3, and again, that I already solved up there, so that's 1. So that's nice. All right, so I get square root of 3 minus 1, and then I'm going to have, I'm just going to rewrite it square root of 3 plus 1 to be consistent. All right, now, you can't have radicals in the denominator. Now, in the past, we've had things like, I don't know, like 3 over the square root of 2, and you just rationalize it like that. That's because this is a monomial. This has two parts. So we have what we call the conjugate, where it looks identical to that, but it's minus, all right? And so then what you have to do is you have to do FOIL. All right, so I get first, which is the square root of 9, and I'll go ahead and write that. Inside, outside is negative square root of 3, negative square root of 3, and last is plus 1. And then on the denominator, we get the square root of 9 again. And then our outside inside will cancel. That's why we use the conjugate. And last is that. All right, so what's going to happen is we're going to end up, we get, this is 3. So I get what? 4 minus what? 2 radical 3. And then this will, again, end up being a number 3 minus 1. And that will be a whole number down there. All right, now at this point, you can't just cancel 1. You would have to reduce both. It's kind of like factoring out. So if you want to factor out a 2, and then you could cancel it. Otherwise, you can divide both of these by 2. So this divided by 2 is 2. This divided by 2 is that. So you can either factor out and cancel your 2's, or just make sure you divide both. You cannot just cancel one of them. It does not work like that. All right, so this would be my exact answer to the tangent of that. And I could check my answer. I could type in this on radians and get a decimal on my calculator, and then I could convert this to decimal and then see what I got.